Armour's article. And that, in theory, should actually help you when you read the articles to get more out of it. Truisms of software development. It's hard and unpredictable. And we're going to talk about that. Yes?
Quick question, but something that's always been on my mind is what's the difference between software development and software engineering?
Oh, it's all the same.
Okay.
I wouldn't. Software engineering really doesn't deserve to be called software engineering. When you compare it to civil engineering, chemical engineering, mechanical engineering, and other engineering disciplines, which have very rigorous educational requirements and very rigorous certification requirements. Software engineering is a highfalutin name for coding. And I say that as a self-professed software engineer for the last 45 years. So I'll use the terms interchangeably.
Okay.
There is no clear. People may come up with different definitions, but now it's all the same. Software specification and estimation are difficult. Estimation is usually done at the wrong time and by the wrong people. Some of you have already said, you've got projects that have gone bad. Well, this is why. It's kind of like, we're going to build an office building on this peak, and it's going to take us 3 years. It's like, okay, and what's it going to look like? Well, we don't know yet. And who's decided this? Well, the CEO of the company. And of course, they don't tell you that there's actually a glacier on the top of the peak. And under that, beneath that, a volcano. So, which gets us to one of my favorite maxims from Spinrad 1998. In creating a new software program, all the important mistakes are made the first day. This is so true. Usually what happens the first day is people don't stop to say, okay, what is it we're really trying to do? What are the realistic issues? So on and so forth. It's like, we're going to do this. We're going to build this great killer app and make a lot of money. As a result, the rate of overruns in terms of schedule and cost outright failure is high. This is another maxim we'll talk about. Not original to me, it's been around for decades. The first 90% of the project takes 90% of the schedule. The remaining 10% of the project takes the other 90% of the schedule. This is true, and the reason why it's true is that, and we're going to talk about this when we talk about Richard or Philip Armour's thing, is there's so much we don't know and we don't realize we don't know it. And we tend to defer all the hard problems to the end. We get stuff working about 80 to 90% and think, oh, it's only going to take a weekend to finish this off. And what we've actually done is we've pushed the hardest stuff off. When we try to finish off the whole project, we have like 8 or 9 or 10 of those hard problems to solve. People matter most. This has been shown time and time again over the past 50 years. The single biggest predictor of software success and failure are the people working on the project. You get a good group of people and they can succeed almost in spite of anything. You get a not so good group of people and you can have the best methodology, tools, everything in the world, and it's still not going to succeed. This is one of my hobby horses, which you'll hear time and again. Organizations ignore or minimize software quality assurance. They also define it down as just testing, when testing is only a tiny part of SQA. We'll have a whole lecture on this. And you have organizational dysfunctions. What are some of the what are some of your experiences with some of these or other things that you have discovered in the course of working, particularly for those of you who've done internships or have actual jobs? What are some of the problems or issues that you've seen in software development? Yes?
That's exactly what the issue is, like the company I'm working at. We're trying to build a training platform for patent translation. Number one, we're just never consistent with, meetings or anything. But two, when I was talking with a contractor, I realized, we don't even realize, we don't even know how to build this because we don't even know what we're building. We're trying to teach, It's like, yeah, do you have any teaching materials or anything like that? Good question. How do our employees normally get trained? there was no documentation, anything. I'm thinking, I'm trying to build something out of nothing, is what I realized.
Yeah.
So a proper understanding of,
A lot of software is just like that. That's you've just described about 50% of the software projects in the world. Tragically enough, yes.
Reorgs every few months.
Huh? Oh, reorgs. Yes.
No testing, no documentation.
Yep. Yeah.
I worked for a team that was replacing another team, and the other team, like eventually anyway, the other team was supposed to train us, and for political reasons, they did not want to train us or give us access to the VMs or anything else. So that was fun.
Knowledge transfer. And we'll talk a lot about knowledge transfer. Yes.
The hardest one I've got is basically cultural barriers. We work with a couple of people in India, and nothing lines up.
Yep.
Everything's different.
That's a serious issue. We'll talk a lot here about the industrial mindset of management. Management thinks that software should be an industrial process, where it's an assembly line and interchangeable workers and interchangeable machinery and so on and so forth. Software development is like a sports team. It really is. And as for those of you who are watching some playoff games this weekend, even really good sports teams can have a bad day and lose as a result, in spite of individual performances. Okay. Why these 3 books? I've actually already talked some about why these 3 books. Okay, chapter 1 of Mythical Mammoth is called The Tar Pit, and he talks about the level of complexity. I forgot to bring my own markers, because ones here are almost always dried up. I'll do this over here. Oh, this is it. How many of you have ever just written a program for yourself? Okay, that's pretty easy, isn't it? How many of you have written a tool or utility for someone you know to use? How much harder is that? It's a lot harder, isn't it? Why? Why is it a lot harder?
Because you have to think about all the different possibilities that will create the code.
Oh yeah. Yeah, suddenly, I mean, when it's your own code, you know what not to do. But if you're turning your baby over to someone else, it's like, no, you're not supposed to do that. Well, you never said that.
Especially if it's dealing with the name of the virus.
So you've got... Now, how many of you have ever worked on a program intended for commercial release? How hard is that? Very hard. Why is it very hard?
There's just so much that goes into it, and so much goes wrong.
And you're basically putting this in the hands of maybe thousands of people who are going to do all the things you don't expect to do. Yeah.
There are also specifications of the company like support you.
Yep.
Never really consider before.
So I'm just going to write commercial here. Now, how many of you have written tools for commercial shipping? In other words, a software tool to actually be used, sold commercially, used by others. How hard is that?
It's so freaking frustrating.
So you have commercial, I'll call it commercial system. Brooks basically says from here to here is 3 times harder, from here to here is 3 times harder, from here to here it's 9 times harder. That's just rough rule of thumb. Part of the problem is knowing what you're writing for, what your target market is. And I mean, I write tools, I still do coding. Usually I'm doing analysis of source code or data files or whatever for a case I'm working on as an expert witness. And what I do is I reinstall Python and I look up on Stack Overflow how to do certain parsing and so on, and I write these very ad hoc Python tools until they're doing what I want them to do, and then I forget about them because I never use them again. That's really easy. If I were writing this as a commercial program, I'd be charging a lot of money for it. So companies often underestimate that shift in difficulty. What are some other things that you found that add software complexity in terms of trying to finish and deliver a product? What gets in the way? Yes?
If you're new to the team, the software itself there's a lot of it. It's complicated,
Yep.
and it can take you months to come to terms with it.
Amen. And that's a very important thing, which is why when we get to Brooks' Law, adding people to a late project makes it later. It's for exactly that reason. What are some other difficulties? Yes?
Other people working on the same file they're working on at the same time.
And changing stuff that you changed?
Not documented.
Yep, and not documenting it? Yes?
I think a lot of things change in scale. I recently had like a 400 gigabyte Git repo, and so even little things like checking out a branch or doing a commit just take forever, right? So as your problem size increases, maybe this is more of a 312 topic, but complexity algorithmically increases as well.
Yes, it does. Yes, hands over here, yeah.
I was kind of along the same lines. The more people you have in the project, you get, it's like a combinatorial kind
It
of
is.
effect.
It is literally combinatorial.
Yep.
And that's a key issue is communications within a project. Yes?
There's not enough resources dedicated to testing.
Oh, yes, yes, yes. Oh, man. You know, and forgive me because there are stories you're going to hear over and over again, but at Pages, this was a startup. We were to do this desktop publishing system. We were trying to close on venture funding. And we finally did after a year and a half. We hired a permanent CEO, Larry Spellhog, great man, good industry experience. But I wanted to hire a director of quality. He said, can't we just have some college students come in for the last 3 weeks and sort of type on it? And I said, no, Larry, that's not how QA works. It's not how it works. To his credit, he listened to me. We hired a director of quality and had a full-time QA staff for the entire development arc. But that is exactly it. QA is the red-headed stepchild of software development. It really is. And I say that because I actually have a red-headed stepchild. Who I love to pieces. But the point is that, no, the resources, QA is seen as an obstacle. It is not seen as a benefit. Yes?
Generalization. So making an app to design any kind of web page is way more difficult than a certain type of web page.
Yeah. Yeah, the more you generalize the intent, function, or output, the more difficult it is. Yes?
Interacting with existing libraries and operating systems.
Oh, yes, yes. As they change underneath you, and suddenly a certain API stops working, or it works a little differently and you don't know that. And you can't figure out why your results of the code that used to work perfectly well suddenly are wrong. Yes?
So I actually work in IT, so it's not exactly the same, but similar. The biggest problem we probably have is just all the legacy stuff.
Yeah.
Because my company has been bought and sold several times. So we have like 800 systems that nobody knew what happened.
Oh, yeah, legacy systems. We'll talk about legacy systems. So now, how many of you enjoy programming? It's probably why most of you are seniors in computer science. If you like programming, you probably would have changed majors by now. What's fun about programming? Why do you like it? Yes, solving problems, creating things.
Super fulfilling when it finally works.
That's so fulfilling when it works. There's nothing quite like it compiled, and look, it's doing what I wanted it to do. What else? Anyone? That's it? That's all the real reason why? Yeah.
It's like a drug.
It is. It's like magic. And this is what Brooks says. He says you're close to pure thought stuff. You are causing things to happen. You're controlling hardware. You're making these wonderful images appear on a screen because of that magic incantation you wrote. Yes?
The product risk is a little less than physical engineering. So, yeah.
I mentioned that I was a microbiology major. I had no problem with my chemistry test, but I was really sloppy in the lab. So I changed to computer science where it's much, much easier to cover up your mistakes. Okay, we'll start a new file here. Start a new program. Yes?
Easy and reliable way to make a lot of money.
Yeah, actually, well, and this is both a good and bad part. We will talk about the level of incompetency in the IT industry. And the reason why is because the demand for IT workers greatly outstrips the supply of qualified IT workers. And it's been doing that I wrote an article on it 25 years ago. It's more true today than it was then. I'm sure you don't want to be a hero. You don't want to be the first 2.5-hour lecture here. So we'll go. Now, problems with programming. What are the things you hate about programming? Yes?
50% of the time is spent debugging,
Yep.
You're debugging with a deadline.
at least.
Yes, debugging with a deadline. What else? Yeah.
Refactoring other people's code.
Oh yeah, refactoring. I was hired by Apple back in like 1988 on a contract basis. They had bought a multimedia package that they were using for self-running demos. They hired me to fix bugs and to add some new features to it. And there was this one major routine that was written in Pascal. It was probably about 17 pages long, single subroutine. Probably had about 30 go-to statements in it. Going back, we're not talking nested go-tos, we're talking about stuff jumping back in the middle of other go-to arcs and so on. And I spent about a week butting my head against it. Then I sat down and figured out what I was supposed to do, and I threw it away and rewrote it from scratch. The final version was about 2.5 pages long. I did everything in 17-page version. So yeah, legacy code can be a nightmare. What else? Yes?
Moving targets.
Moving to, oh yes. No, we want this feature. Oh, we have to add this feature. You want this feature too. Oh yes. Oh, but you have to change this one. Oh, this doesn't work. You want to change this. Yes?
Learning a new language after you just figured out all the shortcuts in the last language.
Oh, you know, I'll warn you up front, the glory and the bane of IT is you're going to be learning for the rest of your professional life. I still learn new stuff on a daily basis. I have to, I can actually be pretty lazy in that, but I work as an expert witness in litigation involves computer technology, which means I am constantly hired for new cases that use technology that I've never used before. It's like, okay, I have to figure out how to analyze the source code. It's kind of like, you know, I've got HG11 assembly language running a pump that injects fluid into you, and I've got to figure out the hardware architecture and software architecture and what it's doing to see whether or not it infringes the patent. So, keeps me from going C now, yes?
How do you stay on top of this?
How do I? On my case, it's pretty much on demand. If I have something I need to get done, you know, if I have a new project that's using the latest technology, I have to study it. I read a lot of stuff online. I don't code as much as I used to. I don't do much coding for fun anymore. Not because I don't like coding, but mostly because I'm old and lazy. But I do still, as I mentioned a few minutes ago. I had a case, when was it? I just started last year, where I had to do source code analysis of bodies of Java and C++ code. So I you know, installed a Python IDE and started writing code to let me go through and do analysis, including part of what I had to do was nested analysis, basically to say, okay, if this object class is called, what other object classes does it call? And if those are called, what do they call, and so on. So I could actually compare two bodies of source code and say what was being used and what wasn't. Plus, I have like 4 large 7-foot bookcases filled with technical books. Part of that, a lot of it, I used to get rid of my technical books on a regular basis until I started doing expert witness work. Then I found myself doing things like resurrecting source code under Windows 95. So now I have all my technical books. I haven't thrown a technical book away for 20 years. The product is often obsolete before it's complete. Debugging has at best linear convergence. How many of us have had that sense that, oh, I know there's only a few bugs left. This should just take me a few hours. And like 3 days later, you're still trying to track down that one last bug. It's much the way as, you know, delaying hard problems for last. It is the hardest bugs that last the longest. Oops. Peopleware. First chapter, This is the important point, and this is one of the big things in the class. Listeners said that for the overwhelming majority of the failed projects we studied, there was not a single technological issue. Wow. They were sociological. In testifying before Congress, one of the statements I made, just because it sounded clever, I said, indeed, despite all this literature we have as to why projects succeed and fail, they still fail on a regular basis. Big, massive projects failing. Multi-billion-dollar projects failing. And I said, when asked why this is the case, one could just as easily cite the 7 deadly sins. Pride, envy, greed, sloth, lust, anger, gluttony. Said it's as good as answer as any and better than most. Most projects fail not for technological reasons. They fail for sociological and political reasons. Because people weren't willing to believe how hard the problem was. They weren't willing to do the right thing. They wanted to force it through. And the point they make here is the main reason why organizations tend to focus on the technical rather than the human side is not because it's more crucial, but because it's easier to do. Oh, let's go to Agile. That'll solve our problems. Even though you have no one on your team who's ever delivered a successful project using Agile methodology. Magic bullet. We're going to talk about silver bullets a lot. How many of you have observations along these lines about failed or failing projects? What are some observations? Everyone's nodding your head. Yeah, that's what we've seen. Any specific case studies or issues you want to bring up? One's like, no, let's get through the slides. Okay. Now, accelerate chapter 1. Go read the book. I'm not going to go through this slide. Okay. I actually have another set of slides to do, but here's the to-do next week I put on this thing. Okay, get your GitHub ID, send it to me, log into the client, start proposing projects. You can propose as many as you'd like. I'd say everyone propose one, but then we'll end up with like 50 projects. Start proposing projects, or if you see one you like, just go and edit this page and say, yeah, me too, I like this project as well. And then we're going to vote on projects next week and try to narrow this down. Get on the Slack. You have the invite and the 2 emails I've sent out. We're going to talk about 5 words of ignorance in just a second. Go ahead and read this reading. It's on the class calendar schedule. First chapter of the commandment, first chapter of the 1 and 2 of Accelerate. 5 orders of ignorance. And let's talk about the 5 orders of ignorance, and we'll be done for the day.
Real quick.
Yeah?
Is there a podcast to watch this week as well?
No, I don't think I have the first podcast until either next week or the week after.
Cool.
So don't worry about that. Okay, there's Armour. Now, this is an appendix in a book by Philip Armour called The Laws of Software Process. I've owned that book for probably 15 years. I had never read this appendix until I started teaching this class. This is something that Chuck had as mandatory initial reading. And it's mandatory initial reading here because this may be the single most important thing you read in this class. It's as important as everything else is. Because this gets at the root of why software is so hard. Software is not a process, it is a knowledge storage medium. We write software to encode knowledge of how to accomplish tasks, how things work, how things have to interact. And if we don't have the knowledge to encode, we can't write the software. In other words, if we don't know all we need to know about solving the problem, we can't write the software. We don't know yet. And we may not know everything. We may not know that we don't know everything. That's what we're going to talk about here. We seldom have perfect knowledge ahead of time. If you have perfect knowledge ahead of time, How many of you have implemented, say, quick sort or one of the standard sorting algorithms? Okay? If I tasked you in this class, do a quick sort implementation, how hard would it be? It's like you open a book or you go to Slack Overflow or, Google it and bam, 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 and that's it. How much value does that algorithm have in what you've just produced? None. Everyone has it. There's nothing new about it. There's no invention. There's nothing new that you have done. And if you have perfect knowledge ahead of time, then you're not solving anything necessary. Valuable software comes from exploring potential solutions to a problem and discovering how to solve them, and along the ways discovering things that you didn't know before you started. In this process, we determine what appears to work and what appears to not to work, and those are both important tasks. Some of you have talked about inheriting software from others. How many of you had the experience of inheriting some legacy software that you now have to make changes to, and thinking of a solution and saying, oh wait, why don't we do this? And you try it and it doesn't work, and someone says, oh yeah, we tried that like 6 months ago and it doesn't work. I've had that. It is important to maintain knowledge about what doesn't work as what does. Now, there's some hands, some comments. Yes?
In terms of maintaining that knowledge, what would you recommend? Because my initial thought is just write in as a comment, we didn't do this because reason. But is there a better way to make documentation of that?
There's the real trick. What do you write down? Now, how many of you like writing documentation for code? Well, a few of you do. How many of you don't like writing documentation for code? Yeah. Oh, code's self-documenting. Sadly, the code is usually never self-documenting for exactly this reason. It doesn't capture what you tried and didn't work because you usually deleted that code. Sometimes it's really bad is you have code that didn't work and you leave it sitting around. So you have dead code and people are trying to figure out what it does until they trace through it long enough and see it's never being called. Then they're wondering, why is this never being called? Oh, that doesn't work. Why did you delete it? Well, we didn't want to delete it. I wish I had an easy answer for you. It is one of the challenges because it's how do you pass on this knowledge? How do you do the knowledge transfer? Someone else made a comment about the team not wanting to pass on information to the other team. Sometimes they don't want to, sometimes they're just too lazy to, and sometimes they just leave and you're picking up code that you have no idea what it's supposed to do.
Yeah, I was going to say that the company I entered for last summer, the way they did it is they rolled out the documentation into a different platform, I think, last year. And it's a wiki pages. And then we would go there and sort and try to see what they have tried.
And we'll talk, and you'll actually see this when you read Mythical Manlook, you'll see the project workbook concept. Now, Brooks was writing about this back in the mid-70s, so he's talking about actual physical documentation, but having a wiki, a website, somewhere to capture the documentation is important. Now, what happens along the way? Problem of late discovery. How many of you have been coding, working on a project individually or as a team, and you discover some major roadblock well into the project? How many of you have been there? I've been there. What's that like? What happens? Any observations? What's it like when you suddenly hit that roadblock?
I think it's usually just what's the quickest way to shortcut around this thing. It's a problem and we need to get this finished.
And it's not necessarily the best solution, but that is the usual solution, yes.
Feel a lot of stress.
Oh yeah. It's like, wait, this isn't working. What happens when you're coding something that's supposed to have this is an actual project I reviewed. They were supposed to be processing overnight credit card charges, and they had a 2-hour window to charge it, and their current system being developed required 20 hours to do it. It's like, we have to speed this up by a factor of 10 to get there. Yes?
You're fighting the sunk cost fallacy. You're saying whether or not you actually need to have this feature or not.
And this, again, as I've already said, something you'll hear me say a lot. your most powerful tool is to throw out features. And as someone mentioned, often they're doing the opposite, they're adding features. Whereas the single most powerful thing you can do to help your software project is to defer or throw away features. Say, we're just not going to do that. Because that reduces the complexity. You can cut out some of those roadblocks and say, we're only going to get to X and we'll worry about that later. And as I said here, the code will often contain artifacts of dead ends, but not be labeled as such. So this is what software development is much like. We start in this big open field. We see this peak, this is where we're going, and we start to push through the forest. And we find ravines, and we find streams, and we find blocks, and we find sheer cliffs, and we eventually, if we're lucky, make our way up to the top. I've done something like this in real life, but I'll save that for later. So what you have in the process here is that as you're doing development, the solid line is your actual progress. The dotted lines are all the dead ends that you went off in and then had to backtrack and keep going. This is what coding so often looks like. It's not a smooth, straight highway and yeah, we're going to do X and then Y and Z and do that. It is stumbling through the desert. So, 5 orders of ignorance. And you're going to read all this, so I'm not going to spend a lot of time. But 0 order is, I know something and I know that I know it. First order is, I don't know something, but I know that I don't know it. I don't know how to make this work yet, but I know that I don't know it. The third order is, I don't know something and I don't know that I don't know it. This is the one that really gets you on software projects. That there's some essential problem to be solved and you don't know that yet. And so you think, you're looking at your schedule and everything's looking great. Yeah, we're going to do this, we'll do this, we'll do this, and it'll all be done. And you do this, and you do this, and you do this, and suddenly you uncover some brand new problem that must be solved for this to go forward, and you have no idea how to solve it. And you weren't aware of it. And all your coding to date has been absent of knowledge that you're going to have to deal with that. So guess what happens sometimes? You have to backtrack. You have to throw stuff out. It's like, oh, we've got to go back. We've got to roll back like 10 versions here and re-engineer something back here so we can account for that particular problem. Third and fourth order, you'll read about them. I don't care about them for software. It says trying to be complete. So here's what we got. Order 0, I know how to complete the system. First order, I know what I need to find out, go to Stack Overflow. Second order, I don't know yet what I will need to know. We live in the second order more often than we think. Third order, I don't know about Stack Overflow. I don't know how to find out what I don't know about solving the problem. And fourth order is, I'm a manager. It's true. Trust me. Most managers come from business backgrounds. They have 0 clue on software. These are his cycles as far as how you resolve your ignorance. Again, you're going to read this. So your key problems are that the more knowledge you acquire, it will uncover more of your lack of knowledge. Now, as the further you get along in the code, you're going to say, oh, we figured out how to solve this, but we just have 3 more problems now, with new problems that have come up because of this. We have no empirical way to measure knowledge. And the critical measure of knowledge in software is that of the knowledge not in the software. It's the stuff we haven't put in yet that is required before the software will function as we hope and need it to function. Any observations and thoughts? We're getting late here. I see a few of you dozing off. So we're wrapping up here. You'll read this article, but I wanted to give you a good background on what you're going to be reading in these chapters in this article, because this is some of the most important stuff you're going to read, and what you're going to find is that it applies to all of you who are currently working in software. You're going to go back just after this reading, and you're going to go back to your jobs and say, oh my gosh, this is exactly what you're doing. This is why management doesn't understand. This is why we've been stuck in this problem for so long. A lot of your readings are going to be along those lines. Any questions, thoughts, observations? Anyone? Yes?
Can you explain that last point again? I'm not sure I understand what's the knowledge that's not in the software? I don't understand.
It's the stuff you don't know you don't know. Okay. The knowledge that's not in the software is the knowledge that has not been implemented yet, but will be essential to acquire the desired results of the software. And you get to a certain point, and it's like, we can't get the software to do X. We're going to have to come up with something new, and you may not know how to do that. Sometimes you may never know how to do it. A lot of software failures is you get to a certain point and realize you're attempting something that, if not was not impossible, at least is outside of the scope of what you're trying to do. So it's useful to think of software in terms of encoding knowledge on how to solve the problem at hand. And the question is whether or not you have all the knowledge you need. We tend to assume we have the knowledge we need, or it'll be easily discovered. Sometimes it can drag out a whole lot longer than you think. It can be far more complex. And, hey, you're free. Any other questions or